Hi everyone, today we are going to present our article critic titled LAM Additive Manufacturing, a fundamental review on mechanical properties, common defect, dominant processing variable and its application. So let's get started with our presentation.
Hello, bonjour Exinian. Today we're gonna talk about problem statement. So the challenges of additive manufacturing face significant hurdles regarding component reliability due to recurring defects such as porosity, lack of fusion, and distortion. By optimizing products, it's difficult because final component quality, density, surface finish, and mechanical strength depend on complex interactions between various processing variables. For example, laser power, scanning speed, or powder feed rate. Last but not least, high equipment cost, high energy consumption, and lack of direct comparability between studies using different materials, machines, and conditions present major obstacles to industrial adoption. The main question is, how dominant processing variables in laser additive manufacturing, specifically powder bed fusion and directed energy deposition, influence component quality, common defect formation, mechanical properties, and industrial application. Next.
Now I will explain about the methodology used for this study. The authors conducted a literature review by analyzing and comparing previous studies related to laser additive manufacturing, known as LAM. The review focused on two main technologies, which are powder bed fusion (PBF) and directed energy deposition (DED). The authors also examine how important processing parameters such as laser power, scanning speed, and powder feed rate. These parameters can affect the quality and performance of the final component. Besides that, the study looked at the mechanical properties and common defects such as porosity, cracking, and lack of fusion. The authors review the industrial application of LAM and how it can be used in different industries. Overall, the methodology helps us understand how different LAM technologies and processing parameters affect the final product.
Main findings. The first one, parameter property dependency. Processing parameter, for example, laser power, scanning speed, powder feed rate, directly dictate melting behavior, material deposition, density, surface finish, and overall mechanical performance. Second one, industrial utility. Laser additive manufacturing enables the production of highly complex geometries, led with structures and component repairs that are difficult or impossible via conventional manufacturing, service high-value sectors like aerospace, automotive, biomedical, and energy. Third one, interconnectedness. Final quality in laser additive manufacturing is not governed by a single isolated variable, but by the holistic interaction between material type, machine characteristic, processing condition, and the manufacturing environment. And lastly, identification of core defects. Improper parameter selection leads directly to critical defects, primary porosity, cracking, lack of fusion, and also thermal distortion.
I will explain the key limitations of this article. Firstly, the article has a broad and unfocused scope. It covers many topics such as technologies, defects, process parameters, material properties, and applications. While this gives a broad overview, but it does not discuss each topic in depth. Second, the article lacks a systematic methodology. It does not clearly explain how the references were selected, which reduces the transparency and reproducibility of the study. Another limitation is cross-study comparability. Since different studies use different materials, laser systems, and equipment settings, it is difficult to make direct comparisons or draw general conclusions. The article also relies on secondary data instead of conducting new experiments, so its conclusions depend on the accuracy of previous studies. Finally, it gave limited attention to industrial factors such as equipment costs, and environmental impacts, which are important for large-scale implementation. Overall, although the article provides valuable information, its limitations suggest there is room for improvement in future research.
Hi, my name is Muhammad Arish Razani bin Shafizat, and I will continue for the significance and relevance of findings. So, for significance and relevance of findings, there are 3 points that I will be explaining to you. So, the first one is engineers and designers. They provide vital insights into how process parameter control directly prevent structural failure, assisting in product optimization and quality assurance in mechanical engineering. So, their role in this thing is to make sure that everything goes smoothly. The second point is industrial production. So, in industrial production, it highlights LAM's ability to reduce material waste, enable component repair, and manufacture complex lightweight design across key sectors such as aerospace, automotive, medical, and energy production. And last but not least, the third point is academic or educational value. It serves as an accessible single sources, foundational reference for students, researchers, and newcomers seeking an integrated view of laser-based additive manufacturing system, which is very important for the future use. And that's all from me. Thank you very much.
In conclusion, in terms of strength, comprehensive, multifaceted integration of technologies, parameters, effects, and application into a single review. Second one, effective use of visual scaffolding, figures and tables to structure technical information logically. Successfully establish the link between processing parameter control and defect mitigation, and also high academic relevance for mechanical engineering and sustainable manufacturing fields. And the second one is the limitation, non-systematic literature collection methodology, difficulty generalizing finding across different machines and material system, and lack of original empirical test data. Surface level treatment of economic and environmental impacts. And the final verdict, the review paper by CBC ETAL in 2023 serves as a strong foundational resource that effectively maps the broad landscape of laser additive manufacturing for engineers and researchers. While it falls short in methodological transparency, deep comparative rigor, and coverage of economic and environmental realities, it is holistic perspective make it a solid, worthwhile contribution to mechanical engineering literature.
That's all from us. Thank you for listening, and we hope you enjoy our presentation.